let us learn together about the molecular orbital theory, which states that the molecular orbital theory is the method for describing the electronic structure of molecules by using quantum mechanics. Molecules, its geometry is determined by molecular structure, orbitals, by using the theory called valence shell electron pair repulsion. Today let us see together how the electrons are arranged, and once two atoms combine together, how they form bond between them. Now let us consider about the cyanide ion, which is formed by carbon and the nitrogen. These are two different atoms. Now we consider carbon and nitrogen, they form cyanide ion. This we use valence shell electrons, which are them which participate in bond formation. In any atom, the electrons which participate in bond formation are valence shell electrons, which are free, are not tightly bound as that which are close to nucleus. Now let us see how these electrons are arranged. In carbon here, we have two orbitals which are present in valence shell, 2p and 2s. Starting with 2s, we have 2s for carbon and 2s for nitrogen. But for nitrogen, this bond will be below this way, since nitrogen is more electronegative than carbon. Then we have 2p, and here we have 2p. This way. The same, this 2p will be some extent below this 2p because nitrogen is more electronegative. P have three orbitals, and in S there is one orbital. The p orbitals are spinning in three directions: px, py, and pz. In carbon, there is 2s2 which possess two electrons, and in nitrogen there is 2s2 which possess two electrons. Once they combine, they form another orbital called the molecular orbital, one at the lower energy level and another at the highest energy level. Electrons from each atomic orbital, they will first fall to the molecular orbital at the lower energy level and they facilitate bond formation. 1, 2, and the remaining electrons will be here. 1, 2. These electrons are falling in the orbital according to the Aufbau principle, which states that in filling electrons, the lowest energy level available are filled first, followed by the highest energy level. And according to the principle of nature, always the nature move toward the direction of low resistance. The substance tend to move toward the position which there is no resistance. Now electrons, they will first fall to this orbital this way because there is no resistance. The remaining electrons will absorb energy and jump to the highest energy level. Once electrons fall from higher energy level to lower energy level, they release energy. That energy released exert to the exothermic reaction which facilitates bond formation. For that reason, the orbital at the lowest energy level is called bonding molecular orbital because it is at this orbital where the bond is formed due to exothermic reaction. Now we call it sigma 2s, and this one is sigma 2s star. These atomic orbitals, 6 atomic orbitals, once they combine, they form another 6 atomic orbitals. Now, the one will be at the lowest energy level, and another will be at the highest energy level. Here in carbon, there is 2 electrons in 2p orbital, but in nitrogen, there is 3 electrons in 2p orbital. As it known by Heinz rule, that pairing is not allowed until each orbital is occupied by at least single electrons. And once they pair, that electrons will spin in the opposite direction. Now we cannot pair these electrons because that orbital will be empty. That's why we fill electron, one electron after another. Now in cyanide ion, there is extra one electron which is gained. We have to understand that electron will be gained by nitrogen or by carbon. According to electronegativity, or the rule of transferring of electrons, the atom which is more electronegative has high ability to accept electrons than the atom which is less electronegative. Now in comparison, carbon and nitrogen, the atom which is more electronegative is nitrogen. Now this electron which is added will not be added to carbon, instead will be added to nitrogen, since nitrogen is more electronegative. Now that electron will be in such way. After that, electrons, they will fall from high energy level to low energy level. So one electron from this orbital will come here, and another electron from this orbital will come this way. After that, one electron, this one will come this way, and another electron will come this way. Then we remain with the two electrons. One electron will be at this orbital, and another electron will be at this orbital. Now these orbitals are called pi 2p, and this one is sigma 2p. This one is pi 2p star, and this one is sigma 2p star. The molecular diagram of this carbon and nitrogen, which we call it cyanide ion, can be written by this way, by removing this one, sigma 2s star, pi 2p, sigma 2p, pi 2p star, and sigma 2p star. This is molecular diagram, molecular orbital diagram. The electrons which are filled here, we have total electrons 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now are going to be written this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Attracted to magnet. Therefore, through this, we can write electronic configuration of cyanide ion. The electronic configuration is written by using sigma 2s. Electrons are 2, so sigma 2s2. Sigma 2s star 2. Sigma 2s star 2. Then we have pi. We have pi 2p x2, pi 2p y 2. Then sigma 2p 2. These electrons should be at this. These electrons should be at this. We just move them. These electrons should be filled on this orbital first before this one. And if they are at this one, this is not paramagnetic. Yes, only it will be diamagnetic. Diamagnetic, because all orbitals are paired. All orbitals are paired. Hence, the magnet has no effect with the cyanide ion. No attraction to magnet since all orbitals are paired. Now we can calculate bonding order. Bonding order, which tell how many bonds are found in this atom. The bonding order calculated by bonding electron minus antibonding electron over 2, which will be equal to bonding electrons and electrons to the lower energy level. The orbital at lower energy level are this one and this one. So electrons are 1, 2, 3, 4, 5, 6, 7, 8. We have 8 electrons minus electrons at the higher energy level are this one only. So we minus 2 divided by 2, the answer be is 3. If the value of bonding orbital is 3, this means that there is a triple bond between carbon and the nitrogen. So the open structure will be this way. The total number of electrons are 10 electrons. And these tell the common features for all atoms, for all molecules with the triple bond. Most of them have 10 total number of electrons. Even if you consider nitrogen, oxygen, all of them, they have 10 total number of electrons. So number of electrons also determine the structure of the substance and its properties of that substance. Now finally, we are going to show how the p orbitals, in this there is unhybridized p orbitals which result to the formation of this pi bond. How these orbitals are formed through overlapping. If we have carbon in this one with the nucleus charge and the nitrogen with the nuclear charge, the sigma 2p show the overlapping which form sigma bond this way. This is sigma 2pz, and this we call it pz axis. Pz axis. Then we have unhybridizing px, we call it px, and this is py, unhybridizing. Px will spin in this direction, and the py will spin in this direction. Now px, this is px, they overlap this way and they form pi bond, and the py, they form another pi bond, and this results to the formation of triple bond. First pi bond and the second pi bond. Here there is 2 pi bonds and there is 1 sigma bond. So that is the arrangement. Now you can use this concept to analyze another molecular orbitals for another molecule. These 2 unhybridized p orbitals are the one which facilitate the formation of pi bond. You can find the hybridization of n of each atom. It will be sp1 because 2 p orbitals will remain unhybridized. If we find the hybridization of carbon, hybridization of carbon from this carbon cyanide will be sp, hybridization. Also hybridization, which means that among 3 p orbitals, only 1 p orbitals is hybridized. So 2 p orbitals remain unhybridized, and this is px and the py. They result to the formation of pi bond, which is triple bond. So this is sigma bond at the center, pi bond, this one pi bond which is at the upper part, and the pi bond, these 2 at the lower part. So here there is sp1 hybridization. Okay, that's enough. I think you can see more videos to learn about molecular orbital and its hybridization and how they determine the geometry. I think you can see the geometry of cyanide molecule.